Problem 20 on page 110 might look a little more complicated to you than it is. In this case, we're given a three-dimensional figure, a sphere, and inside that we've managed to jam or inscribe a right circular cylinder. And the problem says find the volume of that right circular cylinder strictly as a function of h. So to understand what that means, if we just focus on the cylinder for a minute, the volume of any cylinder is its base, the area of its base times its height. So the area of its base is a circle. That circle has a radius of small r. So the area of the base is pi r squared, and the height of the circle, according to the figure, is given as h. So without constraining r and h, you can see that the volume of a cylinder is a function of both of these parameters, because you've got to be given a value for h and a value for r squared. But if you inscribe it in a circle, there's a relationship then between r and h. In fact, you can see it right here. If instead of drawing this radius of the sphere at this point, I drew it from the center out to this point, which is simultaneously on the cylinder and the sphere, I can pull this little, I'm going to change colors here real quick, I can pull this little triangle out, and you can see that it has a side of r, it has a hypotenuse of large R, and then this length is half its height, h over 2. Yeah, right triangle. And then using the Pythagorean theorem, that says that this side squared plus this side squared add to be this side squared, or r squared plus h squared over 4 is equal to capital R squared. So that gives us exactly what we want, the relationship between h and r. Define h and you've constrained r. So in this case, since we're looking for the volume of the cylinder strictly as a function of h, let's solve for r. In fact, let's solve for r squared here in this manner. So here is r as a function of h. Let's just now substitute that into this equation, and you're going to find that the volume of the cylinder is pi h times r squared, and here's r squared. And now the volume of the cylinder inscribed in the sphere is given by this relationship if what we're interested in is seeing it strictly as a function of h. All right?